In this video, I'll cover function prototypes. In a nutshell, a function prototype is a declaration that tells the compiler about a function's name, return type, and parameters before its actual definition. Let's take a look at a short code snippet to better understand what this means. At the bottom, I define a function named add that takes in two inputs and returns an integer. The body of this function is intentionally left blank for clarity, but you can imagine that there's any statements that implement this function. I also define a main function. Again, the body of the main is left blank for clarity. Then at the top, I declare a function prototype. This function prototype tells the compiler what function exists in this program without having to understand the implementation. After seeing this function prototype, the compiler knows that a function named add exists. It knows the number of parameters, the type of each parameter, and it knows the return type. Here I only have a single function, but in larger programs I may as well have 5, 10 or even more functions. And defining a function prototype above the main for each function that exists in my file or in my program gives the compiler a good overview of what functions exist. Essentially, the list of function prototypes above the main serves as a table of contents for the compiler. Then when the compiler looks through the main and encounters a function call to any of the functions for which a function prototype exists, it knows exactly if this function call is valid, has the right number of arguments, and correctly handles the return type. Let's take a look at an example to understand how this works. Inside this program, I implement a function named greet that simply outputs a welcome message. Then inside the main function, I make a call to the greet function. This function call results in a compile error. I get the compile error implicit declaration of function greet is invalid in C99. The reason for this is that the compiler starts reading from top to bottom. And when it gets to the line where I make this function call, it tells me that it is not aware of such function. Such function does not exist because the compiler has not seen this function. The function is defined after the main. So what I can do is copy and paste the function signature, add a semicolon, which now serves as a function prototype declaration. Now, having the function prototype defined at the top of the main, when the compiler looks through, it sees the function prototype, knows that a function named greet exists that does not expect any input arguments and does not return a value. So when it sees the function called greet, it knows this function exists and it's a valid function call. When I execute my program, I can see it compiles and correctly ran with the right output. Now for function prototypes, I can also make the parameters explicit. I can type in void to explicitly tell the compiler this function does not expect any input. Running this again, I no longer get warnings, I don't get errors, and it works as expected. Let's take a look at another example. Here I define an add function that simply adds a plus b. And in the main, I make a call to that function and then I output the result. Now when I want to run this, again I get a compile error because the compiler is not aware that this function exists. It has not encountered this function thus far. So again, I take the function signature, I paste it at the top, add a semicolon, and now I have a valid function prototype. Now I can run this program and get the output as expected. What you now start to see is when I have multiple functions in my program and I define multiple prototypes at the top, these prototypes serve as table of contents to the compiler, but also for other programmers that look at my file or even for myself. Just looking at the top, I can see there's a greet function, there's an add function, and with that I have good awareness of what functions exist. Now for any function prototype, you do not need to define the parameter identifier or the parameter name. I could just type in int, int, And running this program, you see that this is still valid. The reason is that for the compiler, the parameter names are completely irrelevant. It only needs to know the name of the function, the number of parameters, and the data type for each parameter, as well as the return type. If you add a parameter name, this is valid, but to the compiler, there's no use for it. When it encounters a function call, such as add, it only needs to know that I pass in 2 integers, 5 and 3, and this is valid. Now for the programmer, it's still a very good habit to write parameter names in the function prototypes, because they give you additional information of what each parameter stands for. Imagine you have a complex function that expects 4 integers and 2 floats as inputs. Defining the function prototypes without parameter names will make it very difficult what the individual integers represent. But if you do define the parameter name, you can give a lot more information of what each input stands for. Now this is very different when looking at a function definition. Here, if I don't define a parameter name, I quickly get a problem because I always refer to the parameter inside the function's body. So I do need to define the parameter name up here so I can refer and operate on this parameter inside my function. If I do have a parameter name defined in the function's signature that is not used inside the body, it's a clear indication that I do not need this parameter. Here's an example. Let's say I have int c and I do not use it inside my function. That obviously tells me that I do not need c and I can drop it for my parameters. As a final note, the parameter names in the function prototype do not need to match the parameter name inside the function definition. So I could write down operand 1 up here and use a down here. In summary, it's always a good habit to define function prototypes, including the parameter names. I hope this gives you a good idea on function prototypes in C or C++. Thank you for watching.